Once humanity gazed at the stars in reverent silence, asking a single question: are we alone in the universe? For centuries, it was a question of philosophy, then of science. And now, in the era of high-precision telescopes, we are closer than ever to the moment when fantasy might become reality. Recent observations using an advanced space instrument have once again stirred the scientific community. Among the multitude of distant worlds, one mysterious planet stood out, a world where unusual gases were detected in the atmosphere. These signals cannot be dismissed lightly. On Earth, such gases have always been produced by living organisms. What exactly did scientists find? How serious is it? And could this be the first evidence that we are not alone after all? Find out next. Subscribe and hit the like button so you don't miss the most important updates. Scientists from Cambridge studying the exoplanet K2-18b have discovered molecules in its atmosphere that, on Earth, can only be produced by simple forms of life. This is the second time that the James Webb telescope has detected potential chemical signs of life on another planet, and the new discovery seems even more promising than previous ones. However, the researchers themselves emphasize that additional data is needed before any definitive conclusions can be drawn. Professor Niku Madhusudan, who is leading the study, said in his laboratory at the Cambridge Institute of Astronomy that he hopes to obtain conclusive evidence within the next 1 to 2 years. According to him, this is currently the most compelling evidence that life may exist somewhere beyond Earth. The scientists detected traces of dimethyl sulfide and dimethyl disulfide in the planet's atmosphere, organic compounds that on Earth are produced by marine bacteria and phytoplankton. Madhusudan notes that he was especially struck by the amount of gas detected. Preliminary estimates suggest that its concentration could be thousands of times higher than on Earth. He suggests that if these substances are indeed linked to life, the planet may be teeming with biological activity. Confirmation of this, the scientist believes, could indicate that life in our galaxy is not at all rare. So what makes K2-18b so unique among other exoplanets? Exoplanet K2-18b, also known as EPIC 2019125552b, orbits the red dwarf K2-18, located 124 light-years from the Sun. Its orbit lies at a distance of about 0.1429 astronomical units, approximately 21 million kilometers, placing it within the star's habitable zone, which extends from 0.12 to 0.25 astronomical units. Although K2-18b completes one orbit around its star in just 33 days, conditions on its surface may be relatively mild. Its equilibrium temperature is estimated at 265 plus or minus 5 Kelvin, around -8 degrees Celsius, and the amount of light it receives exceeds Earth's solar irradiation by only 5%. Observations made with the HARPS and Carmony's instruments indicate that the planet has a radius of 2.71 plus or minus 0.07 Earth radii and a mass of 8.63 plus or minus 1.35 Earth masses. These parameters classify it as a super-Earth. However, its low average density, about 2.4 grams per cubic centimeter, suggests that it is not rocky, but more likely a mini-Neptune. It is believed that the planet's bulk is composed primarily of water, enveloped by a thick atmosphere of hydrogen and helium. Moreover, data suggests it could be a Hycean world, a planet almost entirely covered by deep water. Given its proximity to the star and short orbital period, it's possible that K2-18b is tidally locked, always showing the same face to its star, creating a sharp temperature contrast between its day and night sides. Could the gas detected on K2-18b truly be a signature of life? Or is it merely a deceptive trace of unknown geological processes? If even a 5 sigma level doesn't guarantee a discovery, how close are we really to confirming the existence of extraterrestrial life? And what if planets like K2-18b harbor forms of life that are completely unlike anything we know on Earth? The team of scientists acknowledges that, at this stage, many uncertainties remain. The latest observation does not yet meet the scientific standards required for a confirmed discovery. For a result to be considered reliable, scientists must be 99.999999% confident in it, corresponding to a significance level of 5 sigma. However, the current observation only reaches a level of 3 sigma, which means 99.7% confidence, insufficient for the scientific community. Nevertheless, this already represents significant progress compared to results from a year and a half ago, when the confidence level was only 1 sigma, or 68%, and met with skepticism. Researchers believe that the question of extraterrestrial life is only a matter of time. But even if the 5 sigma level is achieved, it still would not constitute definitive proof of life. Professor Catherine Haymans from the University of Edinburgh, Royal Astronomer of Scotland since 2021, warns that even with such a level of confidence, the origin of the detected gas must be understood. On Earth, it is produced by microorganisms living in oceans, but under the conditions of another planet, it cannot be ruled out that similar molecules may arise from geological processes that humanity does not yet understand. The team from Cambridge agrees with Professor Haymans. They are working with various research groups to explore the possibility of synthesizing dimethyl sulfide and dimethyl disulfide in laboratories without the involvement of living organisms. At the same time, another team of scientists is closely examining the hypothesis of a non-biological origin of these substances on planet K2-18b. Active debates are ongoing not only about the nature of the detected molecules, but also about the structure of the planet itself. One argument in favor of a vast ocean on the planet is the absence of ammonia in the atmosphere. It is believed that ammonia can be absorbed by a large body of water. However, this absence could also be explained by the presence of an ocean of molten rock, which rules out the possibility of life, as noted by Professor Oliver Shortall of the University of Cambridge. He explains that all our knowledge of such planets is based on extremely faint signals, on the light reflected from their atmospheres. Therefore, scientists must extract maximum information from minimal data, including potential signs of life. Scientific debates about the structure of K2-18b continue. Researcher Niku Madhusudan from NASA's Ames Research Center proposed that the planet may be a mini gas giant without a solid surface. However, this hypothesis is also met with skepticism from other scientists, who point out inconsistencies with data obtained by the James Webb Space Telescope. This underscores the scale of the scientific discussion surrounding K2-18b. What if habitable worlds are not rare at all, and we've just been looking in the wrong place? Could K2-18b be the first link in a chain of evidence that might forever change our understanding of life in the universe? If the assumptions about life on the planet K2-18b are confirmed, it could become a turning point in astrobiology and fundamentally change our perception of red dwarfs as environments suitable for the existence of living organisms. Until recently, such stars were considered unsuitable for the emergence and maintenance of life due to their high activity, powerful flares, and narrow habitable zones. However, most known exoplanets orbit red dwarfs, and if even one of them is truly inhabited, it means there could be far more potentially habitable worlds than we previously thought. Despite its extreme conditions, the planet K2-18b is becoming a symbol of a new era in the search for life. Its oceanic structure, the complex chemical composition of its atmosphere, and new data recorded by the James Webb Telescope point to the possibility of microbial life, even in such seemingly inhospitable conditions. This discovery prompts scientists to reconsider the criteria by which we assess planetary habitability and broadens the horizons of future research far beyond our traditional assumptions. Professor Madhusudan acknowledges that the question of life on other planets remains one of the most important in science. Nevertheless, he is confident that his team is moving in the right direction. Perhaps this very study will bring us closer to the moment when humanity can answer the fundamental question: are we alone in the universe? Subscribe to the channel and stay tuned. Discoveries lie ahead that could forever change our place in the cosmos.